Good afternoon, students. My name is Dr. MP Thiruvenkata. I am working as a professor in IT department, Erodu Sengundar Engineering College. Now I am going to take a topic, Introduction to Automata. Every actions in a computer by means of automation. For example, if you are using washing machine, so that is an automated device. So we are putting our cloth inside the washing machine. The machine go for pre-wash, wash, then rinse, add additives, then final rinse. Then after rinse, the machine going to stop the process. So each one is a set of states. Your input is dirty cloth. Finally, it is going to give the washed cloth. So every state is automated. By consuming some input, it will move to the next state, isn't it? Such a way, the computer system also going to work by means of automated manner. So what is automata? So it is a theoretical branch of computer science and mathematical. So without mathematical, there is no computer science, anything else. So it is a theoretical branch of computer science and mathematical. Then, so what is this? It is a study of abstract machines and computational problems. So we already know that combinational logic circuits. So that is also by work by means of zeros and ones. So combinational circuits contain logic gates. So it going to take the value from the previous gate and do the operations. So it's the input is zeros and ones. So such a type of action is going to happen in the automata. So automata is a study of abstract machines and computational problems that can be solved using these machines. So abstract machines also are called as automata. Okay, you can define automata is nothing but an abstract machine. It can do mathematical operations. So to describe, it is used to describe and analyze the dynamic behavior of the discrete systems. So we are using a computer that is a discrete system. It's going to work with zeros and ones. Okay. This automation consists of states and transitions. So every automata is represented by set of states and transitions. Okay. The states are represented by circles and transition is represented by arrows. So there are circles and arrows. So the arrows are used to connect the circles. Arrows used to connect the circles. The state is represented by circles, okay, and transit represented by arrow. Okay. So automation is a kind of machine which makes some string as an input, and this input goes through a finite number of states and may enter into the final states. So there is an initial state, and from the initial state they are going to consume some input, then move to the next state. Okay. So basically it is like a tape. It's like a tape. So here I show the tape recorder. So the tape recorder move by means of our play button. Okay, we can have forward and backward and all, but here the tape automata is represented by means of tape. The tape is moving one side, not both sides. So each tape is split into some of the cells. Tape, we have a tape. In this tape we have a cells. So I show the diagram to that. So this is the tape. So tape having cells, each cell having some input. This is an infinite tape. It can move forward alone, not in the backward, as like as our tape recorder. So I show the tape recorder. It is a sequential. It is work in a sequential order. Okay. But we can move it forward and also backward. That is also in sequence, one after other. It's not in a random order. As like as here, the automation also having a tape. The tape is an infinite tape, and a control, final control is there. After consuming the input, it's moved to the some other state. After consuming 0, it moves to 1. So it is Q1. For example, the state is called as Q0. After consuming the input symbol Q0, that move to the another state Q2. Q2. If it is in the Q2, it consume 1, it move to some other state Q3. Such a way it is going to the final control move forward, okay, and tape move to the one direction. So there is a one direction. There is no two direction, multiple bi-direction. Okay. Yes. So it is as like as tape recorder. Okay. So here I mentioned some of the terminology. Symbol. So what is symbol? Symbols are an individual object. An individual object or an entity. We call it as symbols. So which can be letter or a numerical value or alphabet or any picture. It may be a symbol. So it's an individual object. So one, for example, one is an individual entity. A is an individual entity. B. Okay. So image is a special character. So these are all called as symbols. So collection of finite set of symbols. There is a finite set of symbol is called as alphabet. What is alphabet? So alphabet is nothing but a finite set of this type symbols. It's a finite type. Why? Because of finite type. So A, B, 0, 1. Such a way we are going to mention. And also it is a finite, only two input, only two symbols. It is a finite symbol. So the alphabet is represented by sigma. Sigma is a notation to mention the alphabet. So what is symbol? Symbols are an entity. Alphabets are finite set of symbols. So which is represented by sigma. So we can represent such a way. Sigma equal to A curly within the curly braces A comma B. So this is a way of representing the alphabets. Next terminology is string. It is a finite set of symbols from the alphabet. Finite set of symbols from the alphabet. So the string is denoted by W. It is a common terminology representing the string by W. So we can put modulus of W, which says the number of symbols in the particular string. Okay. Suppose there is an example here. Sigma 0, 1. So there are various strings are generated. From the alphabet. So 0 and 1 are two symbols. So from which we can generate any number of strings. For example, so suppose I have given a constraint. The string length will be 2. So what is this? So only two string value 0, 0, 1, 1. Sorry, there are four values 0, 0, 1, 1, 0, 1, 1, 0. So here I mentioned some of the strings which can be generated from the input symbol, that is alphabet 0, 1. Okay, there are number of possibilities. You can write any numbers. This is not countable. Okay. Yes. A string may have 0 occurrence, so there is no value. Here no value, so I can put some pi. Okay, that is null value. That is called as null moment. It may epsilon, some null values. Some null values. There is nothing, null values. There is no values. That is called as empty string. So normally we denote empty string by double quotes. Empty string by double quotes. Okay, null moment, something else. This is an empty string. So it is represented by epsilon. This is called as epsilon. That is called as null moment. So null moment is without consuming any input, it can move to another state. So I told you that previously. Suppose Q0 is a one state. After consuming an input symbol, it moves to some other state is called as Q1. So without consuming an input, it can move to some other state also. So that is called as empty string, that is denoted by epsilon. Okay, we will discuss what is epsilon and all. Then, so number of symbols in a string. So number of alphabet in a string, that is called as denoted as W. So the length is defined by modulus of W. It gives the count number of characters. For example, so I take this example. How many how many symbols? So that so this considers a W. So here the modulus of W is 5. Modulus of W is 5. This denotes the length of the particular string. Okay. Then next one is language. So language is a collection of appropriate string. A language is formed from alphabet, can be finite or infinite. Finite or infinite. So we are using, so here this is two length string. Here this is two length string. So there is a finite. So here this is a two length string. So I have one question. Suppose I am going to generate a string string which is using zeros and 1, but the starting will be 1. Starting will be 1. So we don't bother about the remaining symbols in the particular string. So that is called as infinite. Okay. So here there is an example. So the language L1. So what language L1 have? Set of strings of length 2. So this is the maximum possibility. So no other than this one. No other than this one. 0 0 1 1 1 0 0 1. So there is no possibilities for generating strings more than that of this. So there is the length is defined. So there is a constraint for generating the particular string, so that it is a finite language. So next one is, so this is a L2, set of all strings that start with 1. The alphabet will be 0, 1. So we have to put equal to here. 0, but also that should be in, okay, it's correct. That should be in curly bracket. So here set of all strings start with 1. The alphabet is 0, 1. So here we can generate n number of language from this above language, so that it is an infinite language. This is an infinite language. Then there are some definitions in the automata. Then formal definition for finite automata. Yeah, finite automata is a collection of 5 tuples. 5 tuples. There are 5 tuples. Q is nothing but a set of states. That should be a finite set of states. And sigma, finite set of input symbols. So here we mentioned that sigma equal to 0, 1. This is the finite set of input symbol. Then Q, then Q naught. Q naught is the initial state. Q naught is the initial state. That should be mentioned with no source of arrow. Then final state. So this is the last state, final state. So F, that is mentioned in F. Then delta. This is the transition function. So delta is a transition function. A state consuming an input symbol, it moves to some other state. So that is a transition. So after consuming one, it moves to some other state. That is called as transition. Okay, I am moving from to somewhere else. There will be a transition. Okay, yes. So I am moving from one state to another state by means of walk. Okay, yes. So here there are two type of finite automata. Deterministic finite automata and non-deterministic finite automata. Deterministic means we have to know after consuming the input, a single input, it moves to the only one state. That is called as deterministic. It consumes one input, it can move to more than one number of states. That is called as non-deterministic. We can't define after consuming a particular input, it goes to which state. That is called as non-deterministic. I will explain later to you. So here there is a transition delta. Q cross Cartesian product sigma, it gives Q. So I have a state and getting an input and move to some other state. So Q, for example, I have a transition. There is a state Q naught. This is the initial state. After consuming the input symbol 0, it moved to the Q1. So we can mention del q0 comma 0 which is equal to q1. That is called as transition. So moving from one state to another state by means of transition function. Okay. Finite automata can be represented by input tape and finite controls. There is a finite automata can be represented by input tape and finite controls. Okay. Tape is a linear tape. Okay. It's going to consume, suppose this is like state q. After consuming an input symbol, it moved to the some other state. Finite control, it is used to decide what is the next state after consuming the input. Suppose, so this state is q0. The finite control in a state q0, after consuming 0 input, it moves to the q1. So there is a input 1. After consuming input 1, it moves to q3. Such a way it is going to move continuously. The tape is infinite, but the control is finite. So what is this? This is an example of a finite automata. So one way means it's move forward or backward. So mostly we think of forward. Okay. Infinite tape broken into cells. One way read only tape gate. This is the read only tape gate. We are going to read alone. Our tape recorder, we are going to erase the cassette and record the cassette. It is not possible. So it is a read only tape. The input having zeros and ones. Then there is a finite control. There are finite number of states. Transition rules between them. So there is a transition rules between them. So a program containing a position of read head, current symbol being scanned, and the current state and the current state. Okay, a program containing a position of read head, current symbol being scanned, and current state. A string is placed on the tape. Read head is positioned at left end. The string is placed on the tape. Okay, we are going to fix the string in a tape. Each cell having a single alphabet. Okay, symbol. Okay, yes. Read head is positioned at the end of the tape. The DFA will read the string one symbol at a time until all symbols have been read. Okay, yes. The DFA will either accept or reject the string. So there may be a chance the DFA going to accept or reject the string. So I already told you there are two types of automata: deterministic finite automata and non-deterministic finite automata. So we can represent this by means of two ways. One is by transition diagram, another is by transition table. So what is transition? What is transition diagram? So transition diagram is a directed graph which can be constructed as follows. So there is a node for each state q which is represented by a circle. So there is a circle that mentioning this state. Here I have a diagram. So q1, this is called as state. The start state having no source with arrow. The arrow has, so here there is an arrow which indicating move from one state to another state. So arrow means that is moving. So there is a forward direction. Okay, yes. So start state there is no source with arrow. Accepting state or final state indicating double circle. Double circle indicating the final state, that is called as an accepting state. The initial state is marked as no source, arrow with circle, arrow with the state. There is no source. So after consuming the input, it moves to the some other state. Okay. So these are all the some representation, some notation for in the automata. So q0 it is the state, q1 it is a state. So there is a transition from one state to another state indicating by means of arrow. So this is the starting state, the arrow along with the state. Otherwise, you have put a bar on the q0. So normally we are using this symbol. For the starting state. So there is no source for the starting state. The arrow indicating no source. This is an initial state. This is also such a way of representation. q0 over bar. Okay, this is starting state. Then qn. This is a final state or n circle, double circle or concentric circle, which says that is a final state. So these are all the notation. What is this? q1 is a state. So there is a transition from one state to another state. Here starting symbol, it is mentioned by two way, and also final state, it is also mentioned in the two way. Okay. So first, so there is an automata. So this is deterministic finite automata 0, 1. So there is a DFA 0, accepting all string starting with 1. So this is the starting state. So this is an example. This is an example. This is an example. A DFA with some alphabet 0, 1 accept the all the strings starting at 1. Starting at 1 means what? 1 0 1 1 0 0 1 0 0 0 1 1 1 1. So whatever it may be, but the string start with 1. String start with 1. So we call it as not DFA. It is an DFA. It's not an NFA. So this is starting state Q0. After consuming 1, it moves to the final state Q1. So Q1 also having 0, 1. So after consuming 1, it moves to the same state. After consuming 0, it moves to the same state. This is called as self loop. This is called as self loop. So this is a finite state automata. How I am saying this is a finite state automata. So after consuming an input symbol, it moves to the only one state. So Q0 consuming one input symbol to move to some other state called as Q1, only one state. So there is no two values 0, 1. So suppose after consuming 1, Q0 is the starting state. Suppose it is 1 means move to Q2 also, means that is called as non deterministic. So after a state consuming an input, it move to single state, that is called as finite automata. If not, it is a non deterministic finite automata. Okay. Yes. Then transition table. What is this? A table is basically a tabular representation of transition. It takes two arguments and return a state. Okay. Okay. So there are row and column of values. The table is having rows and columns. The column corresponding to input symbol, row corresponding to states. The entry corresponds to the next state. The start date denoted by arrow with no source. The accepted denoted by a star. So there we put double concentric circle for mentioning the final state. Here they are using star for accepting the final state, accepting state. Okay. So this is an example. Here there is an automata. Here there is an automata. So Q0 is the initial state. Because of there is no source input. So Q0 after consuming 0 it moves to some other state called as Q1. So Q1 going to consume 0 means going to the same state. Okay. Then Q1 suppose consuming 1 means it moves to the Q2. Okay. Suppose Q2 consuming 0 means same state, 1 is same states. Then suppose Q0 consuming 1 means right reach to the final state. So double concentric circle says this is a final state. Arrow along with the state is called as initial state. So Q1 is an intermediate state. Intermediate state. This is the deterministic finite automata. How I am saying this is the intermediate finite automata. So Q0 consuming 0 it moves to the only one state. And Q1 consuming 0 it moves to another state, only one another state. Suppose Q1 consuming 1 means it moves to Q2. So there is no more state for consuming Q1 by 1. Then Q2 consuming 2 inputs 0 consume same state, 1 consume same state. Suppose Q0 consuming 1 means it moves to the final state. This is the deterministic finite automata. So this is the state diagram. So this is the initial state. This is the initial state. It is mentioned as arrow along with the Q0. So after consuming this input symbol 0, it moves to the Q1. It consumes 1 means it moves to Q2 here. So Q0 to Q1, 0 input, Q0 to 1, Q2. This is the another state. So next one is Q1. So how am I going to choose this state? So I will choose the state which is come from 0 input or 1 input. Either one I can take. So here I can take Q1. Q1 consuming 0, it moves to Q0. Yes. It consumes 1, it moves to Q2. Then Q2 is the final state, so that it is mentioned as a star. So Q2 consuming 0, it moves to Q2. Q2 consuming 1, this moves to Q2. This is the transition diagram for deterministic automata as mentioned above. Okay. So basically the automata represented by transition diagram and transition table. Okay. So this is another example for an automata. Okay. Q0, Q1, Q2, Q3. So basically a question is asked in any examination. So what is they are going to give some input. Is it accepted by this automata or not? Here I can say 1, 0, 1 is the accepting state of the automata. So consuming 1, it moves to Q1. After consuming 0, it moves to Q2. After consuming 1, it moves to Q3. So 1, 0, 1 is accepted by this automata. And also any number of zeros, 0, 0, 0 can loop means it can repeat any number of times. Any number of zeros with 1, any number of zeros with 1 or without 1, okay, it can move to, any number of zeros followed by 1, definitely followed by 1, any number of zeros followed by 1 or 0, then followed by 1, it's going to reach the final state. Okay, so you can represent any string, but that should have 1, 0, 1 or 1, 1, 1. You can put any number of zeros inside. Here and here, not here. If you put 0 means move to here. Okay, yes. Okay, so you can, so the basic one is, the basic string needed for accepting this automata is 1, 0, 1 or 1, 1, 1. So you can add any number of zeros and ones inside it. Okay. So this is the transition diagram. Okay. So why it is a NFA? This is an NFA. Okay. So why I am saying this NFA? 0, 1. So here Q1 accepting 0, it move to Q1, and it is consume 0, it moves to Q2 also. So we can't say which state it can go after consuming 0. That is called as non-deterministic finite automata. So this is the NFA, non-deterministic finite automata. So how I am saying this one? So after consuming an input symbol, it can go to any number, more than one number of state. Suppose here Q1 consuming 0, it moves to same state, or it consumes 0, it moves to some other state Q2. It is called as non-deterministic finite automata. It will represent it in transition table also. So here we are mentioning two states. So such a way of representation is called as NFA. So within this, so curly bracket, you are putting curly bracket which that having different meaning. So after consuming Q1, it moves to Q1 or Q2. That is called as non-deterministic finite automata. Okay. So there is a difference. There is a transition difference. The non-deterministic finite automata as that of the finite automata. That's also having the number of tuple are as that of the finite automata. So this is same. So this is same for deterministic automata and non-deterministic automata. The only one difference is the transaction. Here in NFA, Q into Q cross E, Q Cartesian product with the alphabet goes to state. So after consuming a state, consuming an input moves to another state. But here it can move to more number of states. So that I mentioned here. So there are two input symbols, zeros or 1 or anything have two input. So 2 power q states. So delta transition is, so delta q Cartesian product epsilon belongs to 2 power q states, because we are having two input symbols. So this is my introduction about the automata. Okay. Thank you. Thank you for listening.